Welcome to this lesson on 4.5 Systems of Linear Inequalities. By the end of this video, you will be able to graph a system of linear inequalities related to the solutions of the systems of inequalities. And you will be able to graph and solve a system of linear inequalities. Systems of inequalities. Same rules for solid and dashed lines apply. As before, we graph all the lines, shade all the lines. Remember, plug in 0, 0 into the inequality to confirm which side to shade. True, we shade towards 0, 0. False, we shade away from 0, 0. The solution is the overlapping shaded area. So let's graph this system of inequalities. So we have slope-intercept form here. We pick out the slope, 1 over 1. We pick out the y-intercept, -2. We go on the y-axis, plot on -2, and now we're going to count from here our slope, up 1 and over 1. And we can create our points as we continue throughout. And now I notice there's no line underneath, so I need a dashed line to go through this. To figure out where to shade, there's my 0, 0. It's above the line. If I plug 0 in, we have 0 is greater than -2. That is a true statement. So we will shade above the line. Now we're going to graph this line. Y is less than or equal to -x plus 1 on the same graph. So I'm going to use blue to highlight this one. Our slope is -1 over 1, and our y-intercept is +1. So we start here. Going down 1 and to the right 1 is going to be where we get our next point. And we go down 1, right 1, down 1, right 1, and continue. Do the opposite to create points throughout this entire line. Now we're going to need a solid line because of this line underneath. So we can connect them. And now we got to figure out the shading. If we plug 0 in, 0, 0, plugging in this point, it's below the line. 0 is less than or equal to 1. True statement. So we shade below. And you'll notice that this is my solution where it overlaps along here and along the blue line. This is my solution set. Graph the system of inequalities. If it's not in slope-intercept form, let's change it. So we need to move the x over. We subtract 5x on both sides. We rewrite it. We have -2y is greater than or equal to -5x plus 10. Divide by -2. We have to divide everything by -2. And when we do that, I want you to notice the inequality had to flip because we were dividing by a negative. So now that we have it in our slope-intercept form, we can graph. The slope is 5 over 2. The y-intercept is -5. You can plot -5 down here, and now we're going to count rise over run. Up 5 over 2. Go up 5 again and over 2. And we have our points that we can connect. We had a solid line because of the line underneath. And now we can plug in our 0, 0 and figure out which way we're going to shade. Here's why 0, 0 is easy. This is just going to cancel it out, leaving us with 0 less than or equal to -5. Is that true? It is not. So since this side is false, we're going to shade away from 0, 0. This side must be the true side. Let's graph this one in purple. Our slope is -3 over 2. Our y-intercept is -2. So we go down the y-axis at -2. We go down 3 and over 2. If we go the opposite, we go up 3 and to the left 2. And we've got our points. It's going to be a dashed line because there's no line underneath. And now we can plug in our 0, 0. 0, 0 is above the line. So if we get something true, we'll shade above. If we get something false, we'll have to shade below. So if you plug in 0, we have 0 less than -2. That is a false statement, so we would shade away from the 0, 0. My shading is currently incorrect. So let me get a highlighter here. Our shading should be away from 0, 0. Should be on this side of the line. In which you should see the overlapping region right here would be our solution. This would be the solution down here. Ignore the rest of this because it should not have been shaded towards 0, 0. It should have been shaded away from 0, 0. All right, which system of inequalities is shown in the graph? If we start with the red one, well, where is it crossing the y-axis? At positive 3. And the slope is up 2 over 1. So we can identify the slope as 2 over 1 and the y-intercept of 3. And then we can think about, from this point, is the shading above this 3 or below this 3? So this red line, it's below it. And so our inequality is going to be y is less than 2x plus 3. We chose less than because it is a dashed line. Let's try to find the blue line. It crosses at 4. The slope is down 1 and over 1. So our slope is negative 1 over 1. Our y-intercept is positive 4. And we have to think, are we shading above this line or below it? We are shading above this line. Therefore, we're going to have the equation y is greater than or equal to negative x plus 4. This is my system of inequalities for the graph shown. Graph the system of inequalities. X is greater than or equal to 2. Remember, this is a vertical line at x equals 2. And we shade to the right because to the right is bigger than 2. Y is less than negative 4. This is a horizontal line at y equals negative 4. And our shading is going to be below because y is less than negative 4. And now we can graph this line. Slope is negative 3 over 2. Our y-intercept is negative 2. So we're going to count down 3 over 2, down 3 over 2. We can do the opposite, going up 3, left 2, until we get all of our points. It's a solid line. And now we can test our 0, 0 point. 0 is greater than or equal to negative 2. This is true. Therefore, we're going to shade towards the 0, 0. And our solution happens to be this little shape down here. This is our solution, where if a point on this dashed line, that's not part of the solution, but a point on this green solid line could be part of the solution, as well as all of these points in here. Malia has $1,000 to purchase water bottles and pairs of socks for team fundraiser. $4 for a pair of socks, $3 for a water bottle. Malia needs to buy a total of at least 300 items. Write a system to represent the situation. So you'll see this popped up here, 4x, so 4 times our pairs of socks, 3 times our water bottles. We got to stay less than 1,000 because we have $1,000 to purchase. We don't want to go over budget. To buy a total of at least 300 items, that means my pairs of socks plus my water bottles has to be at least 300. So we need x plus y to be more than 300 in order to satisfy this system. So can Melia buy 250 water bottles and 55 pairs of socks? Let's test it. If we plug in 250 for x and, 55 for x because our x is our pairs of socks, and 250 in for y, we calculate it out. We're good. 970 is less than 1,000. If we check x plus y is more than 300, we get 305. That works. So yes, she can buy 250 water bottles and 55 pairs of socks. Can Malia buy 40 water bottles and 150 pairs of socks? Well, we've got it in the budget. We stay under budget. But if we check 150 plus 40, that's only going to give me 190. Does not work. Therefore, no, because she needs to buy at least 300 items.